Learn VRMR? Come to the special XR community. Hello everyone, welcome to the OpenXR cross-platform development tutorial series. In this series, I will introduce the XI Interaction Toolkit, how to import SDK and configure related environment. First, let's run Unity Hub. This software can be used to manage different Unity projects and Unity editors. We first need to install a Unity editor so that we can develop Unity projects later. Let's click on the installs. If you have not installed the Unity editor before, click on Install Editor. To install Unity editor, I suggest installing the version with the LTS suffix. LTS here means it is a long-term supported stable version. For example, here I chose the recommended version 6.0.0.24F1. Click on Install. Because we may package the developed XR program into the headset to run later. When we install the Unity editor, we also need to install the packaged module of the XR operating system used by the hardware device. At present, XR operating systems are divided into Android and Apple's Vision OS. MetaQuest and Pico both use Android, while Apple's Apple Vision Pro uses the Vision OS system. In this tutorial series, I will be using MetaQuest 3 as my development hardware. So when we install the Unity editor, don't forget to click the Android Build Support package module. We will need it to convert the program into a program that can run on Android later. If you are developing Apple Vision Pro, don't forget to click the Vision OS Build Support package module. Note that if you install an older version of Unity, the Vision OS Build Support may not be displayed. In this case, download the newer Unity version. I will be using version 2.3.20F1 going forward. If you have installed the Unity editor without the necessary package modules, click on the button that looks like a gear on the right, then Add Modules. Select the necessary modules. We can see the indicator indicating which module we installed. Now that we have installed the Unity editor and the necessary package modules, let's start a Unity project. On Unity Hub, click on Projects, then New Project to create a new project. On the top, here we can select a Unity editor version. Right now, I'm on version 2.0.2.3.20F1. Here in the middle, you can choose Unity Development Template. It is set to 3D built-in render pipeline by default. Now, I changed it to Universal 3D. Compared to 3D built-in render pipeline, Universal 3D costs less resources in some cases. That's why I choose Universal 3D template. On the right, here we can change our project settings, such as project name, location, file path, and Unity Cloud Organization. If you don't want to upload to cloud, don't forget to unclick Connect to Unity Cloud. Last step is to click on Create Project, Once creating is complete, we will be brought to Unity Editor homepage. Now let's start importing SDK and configure environment. First, click on File, Build Settings, Platform. Choose the one that your hardware is using. Since I'm developing on MetaQuest 3, I am choosing Android. Click Switch Platform to start changing process. Once this Unity logo is placed after the platform I chose, it means the changing is completed successfully. We will need to package our Unity project into app file so that my MetaQuest headset can run it later. The same process goes for Pico as well. If you are developing on Apple Vision Pro, change platform to Vision OS. Because my current Unity editor does not have the Vision OS package module installed, I cannot see the Vision OS option here. Now let's go back to Homepage and click on Edit, then Project Settings. Then click on XR Plugin Management. Click on Install XR Plugin Management. Click on the Android logo, then click on OpenXR as our underlying plugin. Unity XR's development architecture can be composed of low-level plugins and high-level SDKs. What we just did is to set up the underlying plugins in the development architecture. Now I am choosing OpenXR as my underlying plugin. Since MetaQuest supports the OpenXR standard, we can simply just choose OpenXR as our underlying plugin. Our program shouldn't face any compatibility issue later. Because the Unity project we created uses the old input system by default, this warning is to let us use the new input system. Let's just follow the prompts. It requires us to restart our Unity project. Editor will finish this job for us automatically. Click on Yes to follow. Once restarting is complete, OpenXR should be checked by a check mark. There also should be two new options here below XR plugin management: OpenXR and project validation. There's a red exclamation mark next to OpenXR, which indicates an error. Let's put it aside and deal with it later. Let's click on this computer logo first. Check the OpenXR option. When we develop XR programs, we usually debug them through PC streaming first. When the development is almost done, we package them into the headset to check the actual effect. PC streaming is to run the program on the computer and then transmit the image to the headset. Streaming can be divided into wired streaming and wireless streaming. Wired streaming is to connect the headset and the computer via a USB cable to achieve image transmission. Wireless streaming is transmitted through Wi-Fi wireless network. So what are the benefits of using PC streaming for debugging? When streaming from PC, we can directly view the changes in the Unity editor. You can check the layered structure of objects and the state changes of objects in the hierarchy panel. You can also adjust some parameters of the script on the object in the Inspect panel of the object. You can also check if there is any error information in Unity's console. When we perform streaming debugging on the PC, there is no need to package the program into the headset. Packaging itself takes a certain amount of time, and frequent packaging will have a certain impact on our development efficiency. Therefore, we may be more accustomed to using PC streaming to view during normal debugging. Therefore, I also need to set up the underlying plugin on the PC side. So, to sum up, both the PC and Android sides need to set up the underlying plugin. I just checked OpenXR here. But now you see a red error on the OpenXR Android side. Then there is also a yellow exclamation mark on the OpenXR side of the PC. These are warnings. We need to fix these problems now. Click on Project Validation here. We can click Fix All here and it will automatically fix some configurations for us. Now I am on Android side and I click Fix All. Okay, now there is no red error here. Then we also click Fix All on the PC side. Okay, now let's go back to XR plugin management. Now, I don't see any red error on the Android side. But now there is still a yellow exclamation mark next to OpenXR on both PC and Android. After we click the Fix All button here, we can see that there is still a yellow warning under its list. Ideally, when all elements in this list turn green, it means that all environment configurations have been completed. Now there is an exclamation mark here, which is a warning that we need to repair it. We can click Edit here and it will automatically help us locate where the error occurred. Now we are brought to OpenXR under XR Plugin Management. We need to add interaction profiles that are compatible with the hardware device in enabled interaction profiles. Let's select Android side and then click the plus sign here, then a list will pop up. The configuration files you see in this list are some of the configuration files that OpenXR has prepared for us. They are used to adapt to different hardware devices. I'm currently using MetaQuest, free. We can see here that in the list, there are two configuration files related to MetaQuest. Meta Out Touch Pro controller profile and Oculus Touch controller profile. From their names, we can also infer that these two configuration files are related to the input of the handle. We can just add these two configuration files here. According to my previous understanding, the MetaQuest Touch Pro controller profile is for a self-tracking controller of Quest Pro, which has a built-in tracking camera. But after my test, this MetaQuest Touch Pro controller profile is also applicable to the Quest 3 controller. This Oculus Touch controller profile also applies to Quest 3 controllers. To be safe, we can add these two controller-related configuration files. The same goes for PC side. Add these two controller-related configuration files. After adding the configuration file, there is no orange exclamation mark on the OpenXR side under XR Plugin Management, and all the items in the list under Project Validation turn green. Now that the PC and Android sides are the same, which means that we have completed the environment configuration on both the PC and Android sides. To sum up, this project validation is an environment configuration checking tool. It will check whether some configurations in our project meet the requirements. If there are any areas that do not meet the requirements, a yellow warning or a red error will be displayed below the list. Generally, it will provide a Fix All button, which will automatically repair the configuration. If the automatic repair tool does not work, it will still display corresponding warnings or errors under its list. We only need to perform manual repairs according to its prompts. After all the environment configurations are fixed, a green check will appear in the front of this list, which means that the corresponding configuration has been completed. Some of you may be confused about the OpenXR feature groups here. We have previously introduced that OpenXR defines a set of interfaces, and various hardware manufacturers can implement these interfaces to make their devices compatible with OpenXR. In fact, the OpenXR interface can be expanded. Hardware manufacturers can expand the interface to bring some features of their own hardware into OpenXR. Take MetaQuest support as an example. MetaQuest has its MR features like perspective scene understanding and spatial anchors. These features are Quest-specific features. In the past, when we developed these MR functions, we had to select Oculus on the bottom-level SDK and then select Meta's own development, SDK on the high-level SDK. Now Meta has officially expanded OpenXR and made some of the device's own features compatible with OpenXR. So now if you want to develop Quest's MR function, in addition to directly using Meta's own SDK, you can also use OpenXR's development solution. That is, choose OpenXR as the plugin at the bottom layer, and then choose XRI as the development tool at the interaction layer. In addition, we use the AR Foundation, a general ARMware development toolkit officially launched by Unity and Meta's MR development toolkit for OpenXR. By combining these tools, we can also develop Quest MR applications. The advantage of using this development solution is that we can use OpenXR plus XRI to develop the interactive functions of the application. If I want to expand the application later, for example, add MR functions to it, then my original program does not need to be changed at all. I only need to adapt to the MR-related SDK. If you want to change the platform for development, the interactive functions in the original application do not need to be changed. You only need to adapt the program to the corresponding hardware platform. This is the advantage of using OpenXR as a development solution that is cross-platform development. Now, let's go back to MetaQuest support. We just gave an example of developing a QuestMR application. It also has another benefit. Because MetaQuest is now compatible with OpenXR, you can actually select OpenXR at the low-level plugin. And then the high-level SDK can directly select Meta's official interaction. SDK. It is a toolkit officially launched by Meta, specifically for interactive development. Because Meta's official interaction SDK is separated from Meta's own system, it is an independent module, so it is similar to the XR interaction toolkit and is only responsible for the development of interactive functions. Meta's interaction SDK is maintained by Meta itself. Since Meta has brought its own features into OpenXR, it is theoretically possible to use Meta's official interactions SDK to develop other devices that support OpenXR. Meta's official interactive SDK can also be used to develop headset of other brand. If another headset also supports the OpenXR standard, then Meta's own SDK can also be used to develop these devices. So that is the benefit of expanding OpenXR. It also lists other extensible features here, and MetaQuest support is just one of them. If you want to know more about these extended functions, you can click the question mark here to open its official documentation. After testing, if you are developing a MetaQuest headset and do not check MetaQuest support in OpenXR feature groups, the final package program will be a 2D window application. After checking MetaQuest support, your package program will be an XR application. But when we check this option, we can see a yellow warning on its right side. We click the warning button and it will automatically jump to the project validation window. A specific warning message will be displayed at this location. It means that we are advised to turn off a rendering feature in URP. Otherwise, if we package this program into the headset and run it, it will increase performance consumption. We can close this window first. Find this settings folder in the project folder. URP-related configuration files are stored in this folder. First, we click on this configuration file. We need to remove the rendering feature in this configuration file, which is the occlusion feature under Renderer Features. We right-click on it and click Remove to remove this rendering feature. Then find this URP configuration file and remove this rendering feature from it. Now we have removed all the rendering features that it suggested us to turn off. However, this window stills this warning message. We can try to restart the Unity editor. Now we can see that this warning still exists. Now I have reopened the Unity project. Click Edit. Click Project Settings. Now there are no warning message in project validation. The warning message was this line. You can see a green check mark in front of it, which means that there is no problem with this configuration.